Hello students, in this video we are going to practice how to find indicial equations. So we shall be finding indicial equation for this equation 2x square y double dash minus xy dash plus 1 minus x square y equal to 0. This is equation 1. Now in order to make the coefficient of y double dash equal to 1, I have divided by 2x square the whole equation. So I have got y double dash minus 1 upon 2x y dash plus 1 minus x square divided by 2x square whole into y equal to 0, which is equation 2. Now if I compare this equation 2, where the coefficient of y double dash is 1, with the standard form, I get px equal to minus 1 upon 2x and qx is minus 1 minus x square divided by 2x square. So in order to see whether x equal to 0 is an ordinary point or a singular point or a regular singular point, I check these two limits. So this limit extending to 0, x minus 0 px, so x minus 0 is x and you see px is minus 1 upon 2x, so this is limit is minus half. Then come here. Now if I find this limit extending to 0, x minus 0 whole square qx, so you can see this is x square, and if you take a look at qx, this is 1 minus x square whole divided by 2x square, so x square gets cancelled out and this limit will come out to be 1 by 2. So having seen that these two limits exist, I can say that x equal to 0 is a regular singular point. And if it is a regular singular point, then we will apply the Frobenius method to solve the equation. For solving the equation, we will be needing the indicial equation. So we move forward. So for this, I have a trial solution y equal to sigma cm x to the power k plus m. This is a trial solution with the compulsory condition that c0 is not equal to 0. Now from this y, I find y dash by differentiating this y, and here the power of x is k plus m. So when differentiated, this comes down and the power becomes k plus m minus 1. So y dash is sigma cm k plus m x to the power k plus m minus 1. Then here we have y double dash. So how do I get it? By differentiating y dash. So again you see that power of x is k plus m minus 1. So when differentiated, this power comes down. So I have got sigma cm k plus m minus 1 and x to the power k plus m minus 2. So having found the values of y dash and y double dash, I keep all these values y dash and y double dash into equation number 1 here. This is equation number 1. So when I keep these values here and simplify, what I get here, I have written here it. So this is sigma cm, this bracket 2 k plus m whole square minus 3 k plus m plus 1 whole into x to the power k plus m minus sigma cm x to the power k plus m plus 2. This is your equation number 3. Now I have just simplified this bracket. You see this 2 k plus m whole square minus, now minus 3 is broken into two parts, so 2 k plus m minus k plus m, and this plus 1 is here. Now if you look at the first two terms, you see that 2 k plus m is common, so 2 k plus m is taken out common, and what is inside is k plus m here minus 1, and in these two terms take minus 1 common, so inside you get k plus m minus 1. So now if you look at these two, so you have this bracket common in both of them. So what we are left with is twice k plus m minus 1 and k plus m minus 1, which is equal to 2k plus 2m minus 1 and k plus m minus 1. So this bracket within the first term is simplified to 2k plus 2m minus 1 and k plus m minus 1. So I use this here. So this equation number 3 now becomes sigma cm 2k plus 2m minus 1 k plus m minus 1 into x to the power k plus m minus the second term sigma cm x to the power k plus m plus 2, which is equal to 0. It is 4 and 4 is an identity. Now from this 4 I have to find the indicial equation. So for this let me observe the two powers of x here. One power is x to the power k plus m, other power is x to the power k plus m plus 2. So out of these two power, which is the lower power? It is x to the power k plus m. So observe here two powers, x to the power k plus m and x to the power k plus m plus 2. So the lower power is x to the power k plus m. Now for the indicial equation, I have to find the coefficient of the lowest power of x. So what will be the lowest? This is the lower, but the lowest will be when m is 0. So when m is 0, I will find here that C0 because m is 0. Then 2k plus 0 minus 1. Then k plus 0 minus 1 and x to the power k plus 0, that is k. So the lowest power is x to the power k and its coefficient is C0 2k minus 1 k minus 1. And here even if you put m equal to 0, the power of x will be k plus 2. So this is not the lowest power. Lowest power is x to the power k. So from this identity 4, what I have got the coefficient here, that is C0 2k plus 0 minus 1 k plus 0 minus 1 equal to 0, and this is what indicial equation. Now we know that C0 is not equal to 0. So therefore in this product, if C0 is not equal to 0, so this whole thing is equal to 0. So that means 2k minus 1 into k minus 1 equal to 0. So these are the two brackets and giving me values of k as half and 1. These are the roots of the indicial equation. So here we have found the indicial equation and we have found the roots of the indicial equation. Now one thing that you have to observe, that roots of the indicial equation are equal or unequal? They are unequal. And what is the difference? That is an integer or not an integer. So difference is not an integer. They do not differ by an integer. So this way we find the indicial equation. Just to summarize, I have the equation, I make the coefficient of y double dash 1, then I find these two limits to find the regular singular point if it is ordinary point or regular singular point. Then I apply Frobenius method by the trial solution. Then I find this identity, and from the identity the lowest power of x coefficient को we put it equal to 0, and then we find the roots of the indicial equation. That is the whole procedure. Hope you have understood it. If you have any problem, then again you are requested to let me know.